Hello and welcome back. If you're new to the channel, welcome. And if you've been following along through the PIW-CWG series, thank you for continuing this careful exploration. Up to now, we've talked about persistence, gradients, direction, and how structure forms and moves. Today, we're going to talk about something that sounds harsh at first, but is absolutely central to how the universe works. Most patterns fail. That isn't pessimism, it's physics. The universe is constantly generating possibilities. Fluctuations appear. Structures begin to form. Arrangements briefly exist. But almost all of them disappear quickly. Only a very small fraction lasts long enough to matter. This episode is about why that happens and why it has to happen. Persistence filtering is not a process the universe runs deliberately. There is no referee, no judge, no selection committee. Filtering happens automatically because persistence has costs, and only some patterns can pay them. Any structure that exists must maintain itself against change. That requires exporting entropy, sustaining flows, and staying within stable gradients. If a pattern cannot do those things, it fades out, not because it was attacked, but because it couldn't continue. Most patterns fail quietly. They don't explode. They don't collapse dramatically. They simply stop being reinforced. Interactions overwrite them. Noise erases their fine detail. Gradients flatten, and the pattern dissolves back into the background. From the outside, it can look like nothing happened, but something did. A possibility was tested and rejected. This is why the universe doesn't fill itself with every imaginable structure. The vast majority of configurations are unstable. They don't last because they can't move entropy, can't maintain gradients, or can't survive interaction with their surroundings. Persistence filtering is the reason structure looks rare instead of ubiquitous. This also helps clarify an important misconception. Survival does not mean strength. It does not mean complexity. And it certainly does not mean superiority. It means compatibility with constraints. Simple structures often survive longer than complex ones because they have fewer ways to fail. Complex structures survive only when their internal organization allows them to manage many competing gradients at once. This is why persistence filtering operates at every scale. At the smallest scales, unstable particle configurations decay almost instantly. At larger scales, stars that can't balance pressure and gravity collapse. Ecosystems that can't adapt to energy flows disappear. Civilizations that can't manage coordination costs fragment. The same rule applies everywhere. Patterns persist only if they can exist within the constraints they inherit. Another subtle point is that persistence filtering is not about perfection. Surviving patterns are not optimal in any absolute sense. They are simply viable. They last because nothing forces them to stop. That's a much lower bar than we often imagine. This is also why history matters so much. Once a pattern survives long enough, it shapes the environment for what comes next. It creates new constraints, new gradients, and new failure modes. Future patterns are filtered not just by physics, but by what has already survived. Filtering compounds. This leads to an important realization. The universe doesn't explore all possibilities evenly. It explores them through a narrowing funnel. Each layer of persistence reduces the space of what can come next. Over time, only a small subset of structures remains accessible. That's not design, it's accumulation. From the PIW-CWG perspective, persistence filtering is the engine behind apparent selection without intention. The universe doesn't choose outcomes. It simply keeps what can keep going. This reframes how we think about rarity. Rare structures are not rare because they're unlikely to appear. They're rare because they're unlikely to persist. Many things can form briefly. Very few can survive the filtering process long enough to leave a trace. That includes us. Everything that exists long enough to be noticed has already passed an enormous number of silent tests. It has survived gradients, interactions, entropy, and collapse thresholds that erased countless alternatives. Persistence filtering is why the universe looks structured instead of chaotic, and why that structure is fragile rather than permanent. Most patterns fail, a few survive, and those survivors define the shape of reality we see. Before I close, I want to thank you for taking the time to listen to this episode. These ideas are not meant to be discouraging. They're meant to be clarifying. Understanding filtering helps us understand why structure exists at all. My name is Charles Carroll, and this is part of the PIW-CWG series. In the next episode, we'll talk about information imprint, how the universe leaves marks without intention, storage, or observers. Thanks for being here.